Good morning and thank you for joining us today. This is an important breakthrough in advancing both the worlds of robotics and physical AI. I'm delighted that we're going to be joined today by ABB Robotics President Marc Segura and also by Deepu Talla, Vice President Robotics and Edge AI at NVIDIA. You'll be hearing from them both shortly, after which we'll have time for questions. And if you'd like to ask a question during the event, simply type it in the question box on this page and submit it. Send your questions in at any time and we'll aim to answer as many as possible during the Q&A at the end of the press conference. Now, before I hand over to Marc, let's start with a preview of what's to come in our announcement today.
From the world's first microprocessor-controlled industrial machines, through the birth of virtual programming and simulation tools, to autonomous versatile robotics that see, think, and adapt. ABB Robotics has never followed the progress. We have defined it. Making work faster, safer, smarter. From precision manufacturing to the frontiers of logistics, healthcare, infrastructure, and even data centers. Now, ABB and NVIDIA are truly fusing the digital and physical worlds. Translating physically accurate simulation into powerful robotic training. Creating robots that learn with unparalleled accuracy in the virtual world. Mastering how to build for the future before it even exists. This is the acceleration of industry as we know it. As fast and as precisely as we can imagine it. Redefining how the world is built.
Wow, exciting news indeed there. So Marc, over to you. Tell us more.
Thank you, Nikki, and good morning, everyone. I'm here today to share the next step in our realization of the future of industrial robotics. Today is an exciting breakthrough in making industrial-grade physical AI real through advanced robotics on a global scale. For more than 50 years, ABB Robotics has led the evolution of intelligent industrial automation. As far back as in the 1970s, we were pioneering the first generation of fully electric industrial computer-controlled robots, before introducing later smaller robots, collaborative and mobile robots with the ability to learn in real time and a digital twin simulation, allowing customers to visualize processes in the virtual world. Most recently, over the past decade, we've given our robot eyes through 3D vision, hands through advanced force sensing and precision dexterity, and mobility through autonomous navigation. We have created robots and the physical AI that goes with them that function beyond a fixed world of operating procedures and coding, and they understand instructions that they see or they hear, and then plan the best way to achieve a wide range of tasks autonomously. We call this autonomous versatile robotics, the name for our unique blend of software and hardware that delivers true autonomy and versatility across the spectrum of industrial applications. But for decades, one final barrier has limited the deployment of industrial-grade physical AI at speed and scale. Manufacturers have struggled to simulate real-world conditions, lighting, shadows, textures of the materials that behave just like they do in reality on the factory floor. And that is known as the sim-to-real gap. And that has limited how quickly businesses can design, test, experiment, train, and deploy new automation. But not anymore. Today, we have broken this barrier in a major breakthrough for robotics and physical AI. In partnership with NVIDIA, we are making industrial-grade physical AI real at scale, and right now, not tomorrow. Embedding the power of NVIDIA's Omniverse into our RobotStudio software, we can bring physically accurate simulation directly into our tool already used by more than 60,000 customers worldwide. NVIDIA's accelerated computing allows us to create huge volumes of hyper-realistic images that can be used to train robots in the virtual world. Different lighting, the shadows, different textures, different material properties, colors, everything a robot would encounter on a real factory floor. These physical accurate simulations and the AI foundation models are continuously optimized with real-world data feedback, so the system is always learning and improving. The result is a unified workflow where developers can design, program, test, and validate entire automation processes virtually for any number of ABB robots anywhere in the world. And these real-world robots can be trained on the resulting AI foundation models with absolute confidence, because we are the only robot manufacturer with a virtual controller running the same firmware as the real robot, so virtual learning transfer into real production with 99% accuracy. Instead of needing thousands of physical test runs, prototype, and expensive parts, robots can see and learn and understand inside a simulation that then translates perfectly into the real world, and match precision in both virtual and physical world. Given the many wild predictions around robotics, you might think that this is theoretical or future gazing. It is not. We call it RobotStudio Hyper Reality. We already have pilot programs running with customers, giant customers like Foxconn, tech companies like Workcar in California, and we will be rolling it out to our 60,000 users in the second half of this year. RobotStudio Hyper Reality closes the sim-to-real gap. It makes industrial-grade physical AI truly ready for real-world deployment at scale. And it will fundamentally change how quickly and reliably manufacturers can move new and updated products from design to global production, cutting setup times by 80%, reducing costs by 40%, concurrent engineering, no need for physical prototypes, and hence accelerating time to market for products by 50%. A major breakthrough in the application of AI in robotics for advanced manufacturing, and the next step in our unique history of pioneering robotics progress. We'll show more at NVIDIA's GTC later this month. And now I'd like to hand over to Deepu Talla from NVIDIA. Thank you. Over to you, Deepu.
Thank you, Marc. Hello, everyone. I'm pleased to join ABB this morning. ABB has been a tremendous partner, bringing decades of industrial automation expertise and delivering world-class robots, controllers, and engineering tools that power factories worldwide. Physical AI represents the next frontier of intelligence, moving beyond digital models that simply process text or images to embodied models that can perceive, reason, and act within the physical world. This shift is changing the robotics industry by evolving robots from fixed, pre-programmed machines into adaptable, autonomous agents capable of navigating and operating in complex and dynamic environments. Just as AI moved from basic recognition to deep thinking, robot intelligence is changing too. Today, most robots are specialists. They are excellent at one single task, but they cannot adapt to anything else because they are pre-programmed. Now, we're trying to see and build generalist robots. Like someone with a bachelor's degree, they can handle different situations. However, they lack the expert skills needed for complex jobs. The future belongs to generalist specialist robots. Think of them as the PhDs of the robot world. They combine broad knowledge with deep expertise, making them versatile and reliable. Building these advanced robots requires an open development platform. 3 computers are needed to build these physical AI and robotics. The first computer is what's called the AI factory to train the AI model for the robot. The second computer is to simulate and test and validate the models in the virtual world. And of course, the third computer, the last step, is to bring that into the real world by deploying the AI model that's been trained on the physical robot. One of the biggest challenges for robotics is closing the gap between what can safely be validated in simulation versus what actually happens in the real world on the factory floor. Known as the sim-to-real gap, this limitation has prevented manufacturers from accurately designing, testing robots in the real world. So we've been expanding this collaboration with ABB by integrating our Omniverse technology into ABB RobotStudio. This integration brings advanced simulation and accelerated computing to ABB's unique virtual controller technology, accelerating how thousands of manufacturers can bring complex products to the market. Today, we are helping customers move from concept to production more quickly, safely, and at scale. With that, I'll hand over to the moderator to get the Q&A started.
Thank you very much, Deepu. Great to hear from you. Really exciting science. Really incredible breakdown from both of you as well. Thank you for the extra detail. We do have some questions, as we've said there, both sent in for both of you. We'll start with this one. First of all, to Marc, what is the benefit of the partnership for businesses? Maybe you could elaborate on that one a bit more.
Once again, the benefits are twofold. On one hand, we are enhancing simulation. We make it hyper-realistic. And as a consequence of that, we can have better simulations, taking a broader scope of the system. So hence, we are cutting times. We are removing the need for physical prototypes. That's a big benefit on cost and time. The second one is that within that same platform, we can train high-quality, high-grade AI models that then translate into more skills of the robots, more autonomy, more versatility. So you've got the simulation benefits, and you've got the benefit of more autonomy on the robots, one on the same platform.
Thank you for breaking that down so beautifully. Deepu, anything to add on that one? What would you say is the benefit of the partnership for businesses from your point of view?
Yeah, sure thing. If you look at robotics and automation for the last 50 years or so, it's been deployed mostly in these so-called high-volume, low-mix applications, so things like automotive industry and high-volume electronics. But much of the world is in small and medium enterprises. And the reason it's almost impossible to deploy robots today is because it's expensive for these robots to set up and program by humans. Whereas in these small and medium enterprises, what you need is high-mix type of tasks. And the only way to solve that is to use a reasonably good enough general purpose AI brain. And that's what we're able to do with the latest generation AI technology. And before you actually go and deploy this in the factory or your manufacturing facility, you want to be able to test it in simulation because it's faster, safer, and cheaper. So fundamentally, these two technologies that happened in the last couple of years is what's making this happen today.
Absolutely. Thank you very much for that. We've got a question here for Marc. Will ABB Robotics offer RobotStudio Hyper-Reality as a new version of RobotStudio, or will it be available as a separate version? Great question.
Yeah. Right now, RobotStudio is for free in its basic functionality. But then you've got RobotStudio Premium for our industrial users, and that's a subscription-based model. And we're going to offer RobotStudio Hyper-Reality as well as a subscription model going forward the second half of this year.
OK, thank you very much for the clarity there. Question here for both of you. I'll start with Marc again, though, before we go to Deepu. When will this product come to market, and are there any companies using it already? You did mention a couple, but maybe you could give us a bit more detail on that.
Yeah, we are explicitly mentioning Foxconn and Workar as the two most advanced pilot customers for this, but there are many ongoing. And the most important thing is that the interest is there. This is something the market has been asking us, because there is all this expectation when I can really leverage AI, when I can really leverage physics simulation so I can achieve shorter engineering cycles, less cost, less time. Well, the moment is now, and we are very, very excited about the speed of adoption, because basically we have a huge community, 60,000 engineers, roboticists, deploying literally tens of thousands of robots already ready to jump on it. So we expect a very fast ramp up.
Absolutely. Thank you for that. Very exciting indeed. Deepu, anything to add on that one about your vision on this? Anything that you can foresee?
Yeah, sure thing. I think problems that have to deal with rigid body manipulation, hard bodies, if you will, pick and place, grasp, move things from point A to point B. Because of the advancements in both generative AI as it relates to large language models and video language models and action models, and now being able to actually do the testing in simulation before you bring it to the real world, these tasks are prime for being solved right now as we speak. And I think this is why it's so exciting to partner with ABB at this moment in time to bring this into the real world.
It really is. Thank you very much, Deepu. Question here for Marc. Is this partnership in any way tied to the SoftBank acquisition?
It aligns very well with the future strategy, but this comes from a long collaboration with NVIDIA. NVIDIA is powering our autonomous mobile robots to perform the visual SLAM, the autonomous navigation. And we've been having this discussion for some time. But as Deepu and I said, time is now, because two technologies are maturing, simulation technology and Gen AI. You put that together, and that makes all the sense that at this point in time, and also, again, next week at GTC, we make this really public.
Excellent, thank you very much. NVIDIA is showing humanoid robots here. Is ABB Robotics developing humanoid robots? There for you.
We are all into autonomy, as we said. We've got a bunch of products in our mobile robots for our autonomous grasping features of the robot. And we will, for sure, deliver new embodiments of physical AI. We've got today already more than 150 different shapes and sizes of robots. And it's not just because we like complexity. Yeah. It's because industrial customers require optimization. If you want to deploy at scale, everything will have to be optimized. So you can expect from us, of course, mobile manipulation embodiments. Will that be in the shape of a human or a dog or whatever? Customers will tell us. It's going to be a response to their request for optimal solutions.
Excellent point there. OK, loads of questions coming in, actually. They've gone bananas on there. First one here to you, Marc, again. Thanks for doing this. They've said NVIDIA has partnered with several other robot arm makers. How do you see this partnership helping ABB sell more robots?
Yeah. I'll give my perspective, then also we can let Deepu say. I think the core of this partnership, what makes it unique, is that this is about putting together RobotStudio and Omniverse. So we are giving a platform, once again, where you can have the sim-to-real gap at industrial grade closed. Industrial grade, once again, with our RobotStudio and our virtual controller, we have for years being the reference to simulate something in a computer and deploying it with high accuracy in a robot. Now with NVIDIA, we're enhancing that. We're expanding that beyond the robot and the environment. And if that was not be enough because of Gen AI, that very high quality environment enables a very good training of AI models. You put that together, and once and again, you push it down to reality through virtual controller, hence you have the accuracy needed for industrial grade. So the uniqueness of our partnership is around this software platform and the industrial grade outcome of it.
OK, excellent. Thank you very much. Deepu, did you want to add any detail on that one? Let me know if you want me to recap on the question at all.
Oh, no problem. Yeah, so NVIDIA, we are a platform computing company. We are bringing, for physical AI and robotics, 3 computers for training the robot brain, for testing the robot brain in simulation, and ultimately deploying the robot brain on the robot. And we're providing lots of core technologies from simulation to workflows for reference models, AI models, workflows, and so on. And our job is to work with pioneers like ABB to integrate our technology into ABB's platforms and solutions. So in this case, it is Omniverse, our technology, being integrated into ABB's RobotStudio. And ABB and their partners are experts in deploying real-world physical AI. So our job at NVIDIA is to bring the best technology to accelerate the computation and then help ABB take it to market.
Excellent. Thank you very much. We've got some great questions here. Thank you to everyone sending them in. Will the small and medium-sized companies need specifically trained people to deploy the tech? Do you want to take that one, Marc?
Yeah. The goal is obviously not. And a proof of that is that within RobotStudio, we're already using language models to move away from the need to program. Instead of that, you can prompt. So our goal is that to walk the talk about the benefits of AI, not only on what the robots will do, but also how you use the robots. So anything around the user interface with RobotStudio progressively will leverage more and more on visual language models, to a point that we will move away from programming robots to instructing robots. Then you simulate those robots, and then the result of the training, you push it to the robot. So the goal is with this new product, RobotStudio Hyper Reality, also take a huge step in making robots available for SMEs. And I think that's very aligned also with NVIDIA.
Absolutely. Anything you want to add there, Deepu, before we jump on to the next question?
Sure. So if you look at, as an analogy, we look at when ChatGPT happened in November 2022. 2 fundamental things happened, right? The first one, of course, is the model was general purpose, that it could do multiple tasks. Before ChatGPT, you had AIs that were specialists in one specific task. ChatGPT changed that with being a good generalist model. The second thing was, of course, it was so easy to use for anybody literally on the planet. So that's the same idea we have for robotics too. If we can bring that technology into robotics for making the models more general purpose, and then number 2, of course, making it so easy to use that humans don't need to program robots anymore. You can just teach them or instruct them.
Excellent. Thank you. It was a really good analogy, actually. You explained that really well. Nice illustration. Thank you. You mentioned real-world feedback earlier. What kind of data do you actually use? In example, paint robots work in an environment with paint mist, making cameras inaccurate.
Yeah, that's a very important point, and it will depend on the application. We want to accelerate, and that will come. It's coming with the new controller OmniCore, an absolutely better connectivity of the robot, where, let's say, the edge device is through 5G by default connected to our cloud. And there we've got all the infrastructure to take on all the basics from the robot. Those are the currents, the torques, everything that the controller can give us. But of course, I mean, we need, because of the power of RobotStudio Hyper Reality, we need more of the environment. Yeah. So anything like, I mean, external cameras, external sensors will also be fitting into that. We have the infrastructure for that. It's called OptiFac, which is the core of OptiFac. It's already an edge device to collect all the data inputs, and they will be necessarily application dependent. In paint, some things will have to be measured that are relevant to optimize. In welding, some others. In material handling, most probably is going to be about the cameras and some feedback from, for example, the fingers that grasp the objects. So this is a very important step. It will come with the pack, and we have the basic infrastructure with the connected robot in place.
Awesome. Thank you for being so clear on that one. Another one for you here, Marc. Can you tell us more about the feedback that you've received from industrial customers who've already tried RobotStudio Hyper Reality? What are they saying?
Yeah, I mean, they're really excited. I can explain you, for example, the case of Foxconn. Foxconn needs to assemble a brand new consumer electronics device. They're becoming ever more sophisticated. And in this case, we even want to automate the assembly of small buttons. But the cameras on the real world cannot be used because it's such a small hole. The shadows that are created are kind of messing up the cameras. But in virtual reality, that's not a problem. You can navigate inside. You can teach and train the robot trajectory. So the robots will be trained virtually, but they will operate kind of blindly, but against the real virtual model. So that is enabling, for example, assembly of these very delicate parts that was never possible before. So you're going to have on the spectrum very, very advanced customers like Foxconn that are tackling this mass production, bring it to the next level. But then you've got companies like Workcar in California, which are enabling a small company that does personalized tiles, okay, to paint them one batch each. I mean, one different every time without the need of costly and complex programming. So the feedback is good. Of course, this is software, so there will be software releases as we go, and we will be really looking forward to the massive feedback now that we launch it to the 60,000 users.
Absolutely, and like you said, though, that you're in response to the feedback as well, so of course that's ongoing as well, collecting all of that data. We've got another one here. Can you further explain the shortcomings of simulation software that RobotStudio Hyper Reality overcomes?
Once again, we are including everything that was not in the robot per se. I'll put you an example. All the applications that entail vision camera, the camera in the simulation right now was not more than a drawing, okay? Yeah. You could, of course, use it to understand how the layer would work and the working envelope of the robot, but you could not simulate the real lighting and working conditions. If you got a camera and you've got a stamping machine that is shaking the camera and producing vibrations, or you have a foundry machine that has a lot of steam and that can be on the way of the camera, that you could not teach. You would find it on the field, and the engineering team would have to program on site, would have to teach on site, and that is costly and long. You're going to do all that in virtual. So that is really one of the big kind of shortfalls that we are overcoming here, expanding the scope of the simulation, still keeping the sim to real gap at industrial grade, and as a consequence of that, also you can train industrial-grade AI, physical AI in that environment. So new skills pushed to the robot that otherwise would have become not industrial-grade. Because if you train AI with not industrial data, you don't get industrial results. And that's also what the customers were telling us. You cannot come here, even if it's so fancy, don't come with a 60, 70, 80, 85% result. We want the 99.9, otherwise we don't talk.
Absolutely, I like that. You explained that very well. Thank you very much. Final question. So we are going to bring Deepu in on this one. We've not heard from you for a while, but I'll start with Marc. What industries are ideal for this partnership?
Oh, I said all of them. We hope so.
Everyone.
I mean, we already said. I mean, for the large manufacturers, this is clearly a next step on embedding efficiency on the design, cutting cost of the product development, being faster on deploying and ramping up products and shifting because demand is so kind of uncertain right now. That talks big to them, but at the same time, the simplicity of the user interface, prompting to RobotStudio, get a suggestion for the robot cell, train it all, and then push it to the robot, that should also appeal and enable SMEs.
Absolutely. Deepu, would you like to add anything on that in terms of industries that you see particularly benefiting from this incredible partnership?
Yeah, I think the advancements and the benefits are tremendous, as Marc mentioned, in terms of cutting down the time for development and testing, in terms of cutting down the cost, and being able to do this in the virtual world. Literally every manufacturer, warehouse, retail, pretty much every environment that we know in an industrial setting can benefit from this. And the cool thing about this, of course, is the ease of use is what makes it, even small and medium enterprises can use this. And the technology now with both Gen AI and simulation has become reasonably good enough to solve a lot of these problems, especially as it deals with, as I mentioned, rigid bodies that have to be, grasped, pick and place, and sorted, and so on and so forth. And as we advance this technology, and as many more developers come on this, we can expect to see increasingly these tasks now going to solve in the near future soft bodies, if you will, right? So that can deal with things that are not at all possible today with robotics, but this platform enables all of our customers to, experiment with these scenarios.
Excellent. Thank you very much, Deepu and Marc. It's been great to hear from you. That's actually all we've got time for today. Thank you so much for joining us and for all of those fantastic questions you sent in. Please do check out all of the supporting story assets that are linked below this video player, and there'll be more available over at globalmediacenter.com. As I say, a special thank you as well to Marc and Deepu for sharing their insights and perspectives on this super exciting news. We hope you've enjoyed the session. I know I have.